Hello students, today I am going to discuss about numerical methods, that is the numerical solution of algebraic and transcendental equations. What do you mean by equations? First, let us understand that. An equation is what? If I equate a variable to a constant, I get an equation, right? See, for example, if I consider x, if I equate that to 3, then I get an equation. What is the solution of this equation? X is equal to 3 itself is the solution of this equation. What do you mean by the solution? If I replace the value of x by certain value, that equation should be satisfied. See, for example, if I consider x as 3, so 3 is equal to 3 I get, so that means what? That equation is satisfied. So, if I equate a variable to a constant, I get an equation, right? See, instead of equating one variable, suppose if I consider a polynomial, see, if I consider x squared minus 3x plus 2 is equal to 0, right? Then I get a quadratic equation. How to solve this equation? What do you mean by solution of this equation? See, for example, if I put x is equal to 2, what I get? It is 2 squared, that is 4, minus 3 times 2 plus 2. Certainly this equation is satisfied. Therefore, I say x is equal to 2 is a root. Similarly, if I put x is equal to 1, what I get? If I replace, what I get? 1 square minus, it is 3 times 1 plus 2. So what I get? 1 square is 1, 2 plus 1 is 3, minus 3 times 1 is 3, so 3 minus 3, I get 0 again. That means x is equal to 1 also is a solution. So what do you mean by the solution of an equation? Solution of an equation means I find out those values of x which satisfies this equation. So in this case, x squared minus 3x plus 2 is equal to 0. X is equal to 2 gives me 0. That equation is satisfied. Similarly, x is equal to 1 gives me 0 again. Therefore, the equation is satisfied. Hence, x is equal to 1 also is a solution. Thus, if I consider a quadratic expression, I get two solutions, right? So, this is regarding the equation. Now, what do you mean by algebraic and transcendental equation? See, algebraic equation is what? If I equate a polynomial equal to 0, I get an algebraic equation. See, for example, this one, x squared minus 3x plus 2 is equal to 0. It is an algebraic equation. Similarly, anything like x squared minus 3x plus 2 divided by 2x squared or 2x cube is equal to, say, some constant, say 3. So this also is an algebraic expression. I can certainly, by cross multiplication, I can write this as what? A polynomial of degree 3, that is cubic equation, equated to 0. Right? I can certainly shift this to the right hand side. 3 times 2x cube I can write. So it is 6x cube. So this I can shift. I can write this as 6x cube minus x squared minus 3x plus 2 is equal to 0. Minus x squared plus 3x minus 2. So that is equal to 0. So that gives me a cubic equation. So algebraic expression means what? Algebraic equation means what? If the left hand side is a polynomial in x, if that is equated to 0, then I get an algebraic equation. Instead of this, suppose if I am having some exponential term here, see, for example, if I say x squared times e raised to x plus 3 is equal to 0. Right, this consists of, is this algebraic? No. Why? Because it is an exponential equation. Exponent term is there. Similarly, if I consider, say, simple equation like sin x plus cos x is equal to 0. So again, this is what it is, a trigonometric equation. Like this, if the equation is not polynomial, that is not algebraic, then I get an equation what is called as transcendental equation. So transcendental equation, it may consist of exponential terms, it may consist of logarithmic terms, it may consist of the trigonometric terms combined with polynomial expressions. See, like this, x squared e raised to x plus 3x cube plus 5 is equal to 0. So this 3x cube, it is a polynomial expression, whereas x squared times e raised to x, it is the trigonometric exponential expression. So such complicated equations, they are called as transcendental equations, right? So we go for numerical methods for solving such equations. See, for example, if equations are simple, then certainly we can follow the direct methods, or we can call such methods we call as analytical methods. See, for example, if I say, as we considered, x squared say minus say 4x say plus 4 is equal to 0. What are the roots? See, it's very simple expression. So I can write this as what? X minus 2 whole squared is equal to 0. So what are the two roots? X is equal to 2 and 2. They are the two roots. The roots are equal and equal to 2. So like this, I can find out the solution directly by factorizing, or maybe suppose if I give you an equation like this, x squared plus 4x plus say 10 is equal to 0. It's not that easy to solve this equation. What I do, I go for x is given by what? Minus b plus minus under root b squared minus 4ac by twice a. I go for this method, right? So minus b means it is minus of minus 4, so 4 plus or minus square root of b squared, that is 16, minus 4 times a is 1, c is 10, so 40 divided by twice a is 1. So what I get, it is 4 plus or minus square root of 16 minus 40, that means it is minus 24 divided by 2. So this I can write as what? 4 plus or minus square root of minus 4 times 6 divided by 2. Since the b squared minus 4ac is negative, I get the complex roots here. So like this, these are all called as direct methods. So if the equations are simple, I can go for direct methods, or such direct methods are also called as analytical methods. So I can go for direct methods, and advantage of this method is what? I get both the roots at one step. That is, at a time I get all the roots. So this is the advantage of analytical methods or direct methods, and they give exact roots. So here in the numerical methods, if it is not possible to solve certain equations in direct methods, see, for example, if I consider this only, x squared e raised to x minus say 5x plus 3 is equal to 0. If I give you to solve this equation, so direct method is not possible. So in such cases, we go for the indirect methods, or we call that as numerical methods. So here we make use of certain fundamental equations. See, I see this x squared e raised to x minus 5x plus 3 is equal to 0. I can write this as what? F of x is equal to 0. Right. So here I make use of some properties of the function. See, one of the properties is let A and B are two numbers such that f of A and f of B are of opposite signs. That means what? If f of A is positive, f of B is negative, or if f of A is negative, then f of B is positive. That is, mathematically if I write, that is f of A into f of B. If I multiply them, what I get? If I multiply one positive, the other negative number, I get less than 0. If f of A into f of B is less than 0, then I this condition is satisfied. F of A and F of B, they are of opposite signs. See, if I draw the graph and let F of X be continuous function in A and B. In interval AB, right? So now if I look at the graph of this function, how the graph looks like now. Suppose if I draw the graph, right? So this is my A, this is my B. I assume that f of A is positive, f of B is negative. I assume that f of A is positive and f of B is negative. So if f of A is positive, definitely f of A lies above x-axis. This is A f of A, right? So this point is A f of A. Then f of B is negative means somewhere here. So it is f of B because f of B is negative. It lies below x-axis, right? So now I am having one more condition, f of x is continuous. If f of x is continuous, I should have a curve which I can join these 2 points, A f of A and B f of B, by a smooth curve like this, because f of B is continuous. So I take this as f of B. So f of B is the f of x is continuous in the interval AB. Therefore, it should be possible for me to draw a smooth curve joining A f of A, B f of B, right? So therefore, somewhere it must cut x-axis. So what is the value of y at f of x? So this is the graph of the function y is equal to f of x, right? What is the value of y at this point? Definitely it passes through x-axis, it cuts x-axis, means y value is 0. So if I call this as C, definitely what will be f of C? F of C must be 0, right? So that means what? C is my root. So x